today I am going to be discussing about U-substitution, both algebraic and trigonometric, and this is really a short video because I am only providing 4 examples. So here we have integral of e theta d theta over square root of 6e theta plus to the power of 3. But this is to the power of also, this is an exponent. So we will rewrite this to simplify and so that it doesn't look intimidating. We can rewrite it as e to the power of theta over 6e theta plus 1 to the power of 3 halves. Now we can use U substitution. In finding or in doing U substitution, you must take note that whenever you're trying to find a part that is in the equation and we're trying to substitute it, it has to not equal to dx when we find the derivative, or d blank, d variable. So you could say, like, if we're trying to substitute x as our u, when we derive that, then that's going to be dx, and we can't really use that because that won't replace and cancel out anything in the formula or in the equation. So we use 6e theta plus 1 as our u. And you should also take note that when we use U substitution, your u could be an inside function. So basically, if it's under an exponent or a radical, or it is usually in the denominator. So for this example, as you can see, this is under a radical and even exponent, and also it is in the denominator. So which is why we use 6e plus 1. So we find the derivative of this, and the derivative of 6e theta plus 1 can just be 0. However, 6e theta, we can slide 6 out and just derive e theta, which is, if you know about the formula, then it's just e theta d theta. So 6e theta d theta equals du. Now all we have to do is to divide this by 6, or 6e theta, but as you can see, in the numerator we have e theta d theta. So we divide by 6 so we can substitute e theta d theta with du over 6, and it's also easier to do. Although you can also divide it by 6e theta, it will still get cancelled out. So du over 6 is equal to 6e to the power of theta, e theta d theta. So all you have to do is substitute e theta d theta with the one you just derived. So this is going to be du over 6 over u to the power of 3 over 2. Now here we can slide 1 over 6 to the left side because it is a constant. So we can write this as 1 over 6 integral of du over u 3 over 2. Now it would be nice if we could have used our logarithmic formula here, but since there is an exponent, we cannot do that. However, we can find the reciprocal of u to the power of 3 over 2, or just inverse it. So this will be u to the power of negative 3 over 2 plus times du, and that is now the product formula. So all we have to do is find the integral of u3 over 2, and that can be u negative 3 over 2 plus 1 over negative 3 over 2 plus 1 plus c, and then we can calculate that. And that is going to be negative 1/2. So this is going to be 1/6 u negative 1/2 over negative 1/2 plus c. And you can multiply the denominator here, the bottom. So 1/6 times 1 over negative 1/2. That is equal to negative 1/3. So I can rewrite this as negative u to the power of negative 1/2 over 3 plus c. And that is your final answer. It is simplified. Okay, for the next problem, 2x times x squared plus 5. Now again, x squared plus 1 is our inside function. So we can substitute that as our u. U equals x squared plus 1. Du is equal to 2x dx over 2x. So now that we have 2x dx, we can substitute it in our dx, du over 2x. And now we can rewrite this as 2x times x, 2xu to the power of 5 du over 2x. Then we can cancel 2x and you are left with u to the power of 5 du. And once again, we can integrate that by using the power rule, and that is going to be u6/6 plus c. Remove the integrand here. And we can replace u back to x squared plus 1 to the power of 6/6 plus c. And that is our final answer. For the next problem, we have this integral of x times root 1 plus 2x squared. Okay, so once again, we can find u as our inside function. So it is going to be 1 plus 2x squared. Du is going to be the derivative of that, and this is going to be just be 4x dx. And then we divide it by 4x. Dx is going to be 4. Dx is going to be du over 4x. Okay, now we can replace dx with du over 4x now. So x square root of u du over 4x. And then we can just cancel out the x. You are left with 1 over 4, du over 4. Since 1 over 4 is a constant, you can put that aside onto the left side of the integral, and then you can just have square root of u du. And square root of u is just 1/2 to the power of 1/2. So once again, we can write this as 1 for u to the power of 1/2 du. And then just apply the integral operator. So u 1/2 plus 1 is 3/2. U 3/2 over 3/2 plus c. And then you can combine the denominators there. So 1 over 4 times 1 for 3 and 2. That is going to leave you with 1 over 6 u 3/2 plus c, and then substitute in your u again. So I can write this now as 1 plus 2x squared to the power of 3 over 2 over 6 plus c. And that is your answer. Okay, for the next one, since, okay, there's a sign here, sine cubed y cos y dy. We will use the trigonometric substitution. So basically, all you have to do is use let u equals sine y, yes, because 3 can just this can just represent as sine y cubed. So we let the inside function, which is sine y, as our u. Then the derivative of sine y is cos y dy, and we don't even have to cross or divide because that is already the function we will replace. So now we can just write this as sine, or no, we can rewrite this as u to the power of 4 du, and then no. So we can rewrite this as integral of u3 du, and then again apply the integral function, and that is going to be u4 over 4 plus c, and then you can replace u with sine y, so sine y 4 over 4 plus c, or sine 4 y over 4 plus c, and that is your final answer.